Hello everyone. Do you think computer can solve every problem in this world? And by looking at the power of computer, you may think, yes, computer can do it. Why? Because computer can track your location, computer can say the shortest path for your destination, computer can search anything for you, and it can give any result for you, right? But the answer is no. There are some limitations for computer as well. And this is the subject we are going to deal with. If there is a problem, is that problem solvable or not? That's what we are going to deal with in this subject. In this subject, we are going to learn about how a computer solves a problem. If the problem is solvable, how a computer is solving a problem, how efficiently it's solving a problem, and if not, why it cannot be solved. And everything about this can be covered in this subject. And you might think, why? Right? Why actually I need to learn this all? So imagine a situation where you are solving a math problem and you sat down for 3 hours straight and you are solving a problem, and in the end you got to know that you cannot solve that problem. You know, it's impossible to solve it. And what might you think at that point of time? You might think it's a 3 hours of wasted time, right? But if you know the subject, like theory of computation is a subject where you're going to prepare some mathematical models to ensure, like to say whether a problem is solvable or not. So that's what we are going to deal in this subject. And for even more interesting stuff, I'll give you one more example. Suppose, as part of the computer science course, let's take some examples related to computer. So, suppose you are creating a platform and there is a login page for the platform, and let's say you'll take the input of username as well as password, right? So the user enters username as well as password, right? And there are some set of rules given for the password, like it must contain 8 characters with symbols as well, and it must contain 2 numbers. There are some certain rules for you know generating a password, right? And if he follows the rules which are given by the computer, then only the computer can accept it. But can the computer actually understand what the user has entered? Do you really think a computer can understand a password which has been entered by a user? No. Then how can a computer can actually detect that the password is incorrect or the password is not in the format of what it is expecting? How can a computer actually say that? And that's what we are going to learn in theory of computation. And one more thing which we are going to learn in theory of computation is, let's say uh, you are having a compiler and you write this piece of code, like let's say you write int a is equals to 10, and you write this, and you are writing a C program and you wrote this syntax. And what do you think? This will work, right? But what if I say the same thing like this, int equals to 10? Do you think this is gonna work? And the answer is no, it's not going to work. Why? Because it's a syntax error, right? And how can a computer actually understand that this is not the right piece of code? Because a computer is not a human being, it doesn't know what is right and what is wrong. But how can it actually know that this part of code is wrong? And that's where we are going to develop some set of rules. So these set of rules will actually monitor whatever the system is going to deal with. So this compiler will actually follow some set of rules, and based on that set of rules, these will be processed and the result will be made up. So in the previous slide, I explained something called problems, right? So in order to solve a problem, we need machines. But what are these machines? Let's say these machines are not something like laptops or computers, which are physical devices. You might think that machines are this hardware which does some things for you. No, these are not the machines in TOC. Machines in TOC refer to an abstract computational system. So what this abstract computational system is? So abstract means imaginary. So this is an imaginary computational system which cannot be seen, which cannot be touched. So for example, let us take this example. You focus on this. Here, you focus on this case. Suppose in your college, and near the gate there is a watchman, and this watchman only allows the college students of the respective college, right? And the students of another college should not be entered, and the only thing which a watchman can verify is an ID card. With that, he can know that he is part of that college, right? So what he does, so whenever a student comes, he will take his ID card and he will see whether he is actually part of this college or not. He will verify that, and then he will check whether it is valid or a valid, not a valid ID card, and then he will allow the entry or not. So that's what here is actually happening, right? This flowchart shows a person arrives, he will show the ID and whether it is valid or not, and based on that the entry is allowed or rejected, right? So what is actually happening here? Let's understand that. So first thing is entry of a person, right? So there is a person and he has an ID card, right? And then you check whether this is valid, and if it is yes, then you say you can enter, right? And if it's no, then you cannot, right? So what is actually happening here? The watchman is actually following some specific rules for the entry of the student. He need to check the ID card, he need to check whether it is a valid ID card or not, and based on that rule the entry is decided, right? And now let us understand what is machine here. So in the previous slide, we understood a watchman is checking for the entry of the student, right? But now let us replace this watchman with a sensor based system which can, scan the ID card of the student, and the machine itself can verify whether a person is part of the college or not. So if we have completely replaced with a system, right? And what's the difference between a system and a watchman? The only thing that has been changed here is a physical object. Because in the first case, we have a watchman, but in the second case, we have a system, like a machine, a system which is designed, right? A sensor based system which can, you know, verify an ID card. So, completely different. But there is one thing common in these two, their behavior, right? What they both do, they both actually scan the ID cards and say whether they are eligible to enter the college or not. So this is what they're going to do. So the behavior is same. So this behavior and this behavior is called as machine in theory of computation. So in theory of computation, the behavior of the system is called as a machine. And how a machine, you know, computes based on the set of rules, that is what we are going to learn in theory of computation. And as I said, a machine is an abstract computational system. That means it is an imaginary computational system and it cannot be, touched or felt. So we need something to understand these machines. We need something to understand how these machines work, how their behavior, is represented, how they are actually following the rules. So we need something to represent that, and that's where we are going to use automata. So what is this automata? Automata is the mathematical, or automata is nothing but the mathematical models which represent machines. So whatever the machines are there, as they are an abstract computational machines which cannot be seen, which cannot be touched, they can only be represented by using these mathematical models which we are going to learn in this TOC. And these mathematical models are used actually to solve problems, and these mathematical models are used actually to know whether a problem is solvable or not based on some set of rules. So in one thing, if I say for a definition, an automata is an abstract mathematical model that will read an input and decide whether to accept or reject according to some rules specified. So this is what an automata is. So in the next class, we are going to learn about these mathematical models, and we are going to say whether the problems which we are going to deal with in the next lecture are solvable or not. And that is what TOC is for you. And TOC is a subject which has various uses, and it can be used in compiler designing, it can be used for the creation of programming languages and pattern matching, and in many other fields like testing and everywhere. So TOC is a very important subject, and it requires a lot of logical thinking as well. So I'll clarify everything that's possible in the next videos, and in the next videos we are going to start with the first mathematical model, that is DFA, in the next video. And before that, I'm going to explain some basic terminology which is required for doing DFA in the next video. So I hope You have understood why we need TOC and what is TOC and what is automata and what is a machine. And yeah, that's it for today's video, and I'll continue in the next one. Thank you.